Good afternoon, learners. I am Dr. Munish Kumar Bharadwaj from School of Engineering and Technology. As you know, the topic of today's lecture is design of retaining walls. As you know, this topic is related to your course ET508A, that is Structural Design 1. So today we will be discussing about the design of retaining walls. First of all, let's see what is retaining wall. Retaining walls are the walls which are used to maintain a difference of level on its two sides when we come across the situation that on one side the level of earth or the other loose material is different from the other level of the other side. Means these walls are used to retain masses of earth or other loose material at locations where an abrupt change in ground level occurs. Then how this situation come across? When width of an excavation, cut or embankment is restricted by the conditions of first ownership or use of structure or because of economical restrictions, then this level of different level on two sides of a wall occurs. Now what are the uses? Means where you find the use of the retaining walls. Generally, if you think little about the hilly roads, then on one side of that road there is a high hill, on the other side there is a valley or a river. So to maintain a difference maintain the level of difference on two sides, we require a retaining wall. So you will find the use of retaining wall on hilly roads. Secondary, swimming pool. When we construct a swimming pool, then what happens? We have to excavate first. Then here a level of difference on one side, the level of the earth is high, whereas other side there is a cut. So to keep that earth in a vertical position, we will require a retaining wall. Similarly, in case of underground water tank, we will require a retaining wall. Similarly, if you are constructing a building or the basement of a building, here also there will be a difference of level of the earth. So again we will require a retaining wall to maintain that level of difference on two sides. Another case you will find when buildings you want to construct where filling is required. There also you will require a retaining wall to maintain the level of different level of earth. You will also require the retaining walls in case of ends of bridges. means the abutment of the bridges. So when we provide the wall type of abutment, then these are called as the retaining wall in case of the bridges. Now let's see what are the types of retaining walls. Generally we divide the retaining walls into two categories. One we call as free-standing retaining wall, means it acts as a independent structure. Second type of retaining walls are walls which form part of some bigger structure. In case of free-standing retaining walls, there are different type of retaining walls. First, gravity wall. Second, cantilever wall. Third, counterfort wall. Fourth, buttress wall. In second category means the walls which form part of big structure or other structures, we can count as first basement wall, second wall type bridge abutments, and third side walls of a box culvert. So these are different type of retaining walls. We will take one by one. First of all, let's see the free-standing retaining walls. In free-standing retaining walls, the first example is gravity wall. As you can see from this graphic, this is gravity wall, and in case of gravity walls, the stability is provided by virtue of its own weight. As you can see, this is a massive structure, and this wall is made up of either of stone masonry or plain concrete. So because of its heavy weight, the stability is obtained in this case of the gravity wall, as it is clear from its name, gravity wall. So you see here the gravity wall. This is toe of this wall, this is heel of this wall, and on this side the earth will be retained on this side. This is the front portion. This one is the front portion. Such type of walls are economical up to the height of 3 meters. Means if you construct these walls more than 3 meters, then such type of walls will become uneconomical. So what to do when the height of the wall required is more than 3 meters? Then certainly there are other options with us. We can use other type of retaining walls, and in that category of the next type of retaining wall is cantilever wall. You can use this type of wall up to the height of 7 meters. So the use of means the use of this wall is economical up to the height of 7 meters. As you can see from this figure, this is one cantilever, and which is called as the stem. This is base slab. Base slab is divided into two parts, toe slab and heel slab. As you see from here, earth is retained on this side of the wall. This vertical arm, as I told you, is stem, and this whole of the wall behaves as one-way cantilever slab. This vertical arm or the stem behaves as a vertical cantilever under the pressure of this retained earth. This toe slab acts as a cantilever under the pressure of the soil pressure, which is in the direction of upward direction. This is heel slab, and this acts as a cantilever under the weight of the retained material which is in the direction of a downward direction. So this is cantilever wall. As I told you that this type of structure or this type of retaining wall is economical up to the height of 7 meters. Then again the question arises that then what to do if the height of the retaining wall required is more than 7 meters. Then we can move to the other option, and the other option here is counterfort wall. As you can see from this figure, if you leave these portions, these are called counterforts. If you remove these counterforts from this retaining wall, then this becomes simply a cantilever wall. So what is the need of this counterfort wall then? Means if we provide retaining wall as cantilever wall for height more than 7 meters, then what will happen? That because of the earth pressure due to the retained material, the bending moment in this vertical arm will be very high. Also the bending moment in the toe slab and the heel slab will also be very high. Then what is the effect of it? If the bending moment is high, then to check that and to maintain the stability of the structure, then what will happen, that you will require a high thickness of the stem as well as the slab, which will make the retaining wall uneconomical. Then how to reduce the size? To reduce the size of these different structural elements of this wall, what we are aimed at the reduction of the bending moment. And to reduce the bending moment, these counterforts are used in case of counterfort wall, and these counterforts are provided at a span or at an interval of about 1/3 to 1/2 of the height of the wall. What these counterforts do? Let's see. As you can see from here, these counterforts are connected to the stem as well as to the heel here, and also these are provided at some interval of 1/3 to the 1/2 of the height of the wall. So it is first of all, it is dividing the whole wall into different segments, and also it is providing a support to the stem as well as to the heel. So and as you can see, the earth is retained this earth is retained not on this side. This is the front of this wall. Actually earth is retained on the side of the counterforts in case of counterfort wall. So what happens, these counterforts are concealed under this retained earth, means these are not visible here. The visible face is this front face. So what happens here, that these counterforts subdivide the vertical slab into rectangular panels and support them on two sides in a suspender style, and themselves, these counterforts themselves behave as vertical cantilever beams of T section and of varying depth. As you can see, the depth is maximum here and depth is minimum here. So these act as a T-beam of varying depth. The stem and the heel slab panels between the counterforts are now effectively fixed on three sides. As you can see, this heel slab is fixed here on this edge, it is fixed on this edge, it is fixed on this edge. Similarly, this stem panel is also fixed here, here and here. So this stem as well as the heel slab is now fixed at the three sides and free at one edge only. As you can see, this stem is free at this edge. Here the heel slab is free at this edge. And for this stem, you can see from here that the predominant direction of the bending moment here in this stem. Now the predominant direction of bending and flexural reinforcement now is horizontal, because the action is like that the predominant direction of the bending moment and the reinforcement becomes the horizontal, whereas in case of cantilever wall this was predominant direction was vertical. So this way these counterforts help in reducing the bending moment coming to the stem as well as to the heel slab or the toe slab, thereby reducing the required size or the thickness of the stem and the base slab. So this is the advantage of the counterfort wall in comparison to cantilever retaining wall. Now, other type of wall that we use is called as a buttress wall. Now, as you can see from this figure, this is buttress wall. What is the difference between the counterfort wall and the buttress wall? In counterfort wall, these elements which are called as here buttresses, this and this, there we call it counterfort. And in case of counterfort wall, these are concealed in the retained material, means the retained earth is on the side of the counterforts, whereas as you see in this figure, buttresses are on the front side, means these are visible, whereas the earth is retained on the other face. So generally this buttress wall is not preferred in the field because this doesn't give a good look, first of all, and secondary this is not leaving any space for any other work actually, whereas this facility is available in case of counterfort walls. So this is not giving a good look, as well as you cannot use this space in front. So that is why buttress wall are less preferred in comparison of counterfort walls. Now, whereas if you see the structurally, if you see the behavior of, if you compare the behavior of buttress wall and counterfort wall, then you will find that buttress wall are more efficient in comparison to the counterfort walls. But because of that you can say the drawback that these are not giving the good look, as well as the space in the front cannot be used for any other purpose because of these buttresses. So these buttress walls are less preferred in comparison to the counterfort wall. So these are the four type of our free-standing retaining walls. Now let's talk about the walls which make part of other structures, other bigger structures. So let's see what are the types of these walls. Generally you come across the bridges, and in these bridges, bridge abutments are the walls of this type of category, means in which the walls forms a part of the other structure. So here the main structure is bridge, but this end panel or the end wall is the wall abutment, and this act as a retaining wall. Earth is retained on this side. This is the approach pavement, means road is coming from this side, bridge starts from this. This is the retaining wall, this is base slab, and this is bridge deck. So here this part, this wall act as a retaining wall, and this falls in the second category of the retaining walls, in which we call as a walls which form the part of other structures. Second type of these walls is basement wall. As you can see, this is the basement portion, and this is the floor slab of this structure building. This is wall, and on the other side of this wall is the retained earth, means this is the plot or the field which is on which you are not having the ownership, means this plot is related to the some other person, so you cannot excavate or you cannot construct anything in this plot. So, and you are constructing the basement of the building, then just to retain the level difference, because this is the high level, so because of this basement you have excavated your plot. So because of this level difference, just to maintain this level difference, you will require a wall, means the retaining wall, and this wall is called as the basement wall. So this wall is the retaining wall, and this other part is the floor slab, as you see, and this is the wall of your building. So here this wall, as you see, this is a stem and this is the base slab. So these are used in the basement portion of any structure. So these are the basic different type of retaining walls, falling into two categories: 4 retaining walls as the freestanding retaining walls, and 2 examples I have given to the walls which form part of the other structures. Now, as I told you that these retaining walls are used to maintain a level difference of the earth on two sides, means on one side there is a retained material and other side it is having a empty side, means no material is there, or the material is at a very low height. So here you can assume, or you can just imagine that certainly there will be a pressure of this retained material or the earth on the wall, because on one side it is having the material and other side either it is not having the material or it is having material up to a very low height. So there will be certainly a pressure coming to the wall. Now let's see what type of forces are coming on the retaining walls and where from these are coming. Retaining wall prevents the retained earth from assuming its natural angle of repose. Means, what is the meaning of it? Means if you leave the material or earth or the loose material without giving any support, then what will be the tendency of this material? That it will try to go to its natural slope, natural angle of repose, then it will become stable. But because of that ownership rights. We are not having that much space that we can allow that material to go to its natural form, or to make let it stable at its angle of repose. So we are just restricting that material just to take its angle of repose. So means we are obstructing that material. So due to this obstruction, the pressure of that retained material will come to the wall. And what will happen, that this material will exert a lateral pressure on the wall. Now, what is the effect of this lateral pressure? This lateral pressure will try to bend the retaining wall, and it will also try to overturn, or it will also try to slide. Means under the effect of this lateral pressure, either the wall will bend, it may overturn, or it may slide. So these are the three basic actions that are expected under this lateral earth pressure. Now, let's see what are the forces that are coming on the retaining wall. As you can see, first type of the force is gravity load due to the weight of the material, means the material retained. So the gravity loading of that retained material. Second thing is lateral force due to the retained material or the mass of the earth. So if we see this gravity loading of that material retained, then this is not going to pose any serious problem as far as that stability of the retaining wall is concerned. But this second type of force, this lateral force, this is really the major villain as far as the stability of the retaining wall is concerned. Means we have to cater, we have to take proper steps to safeguard the retaining wall or make the retaining wall stable against this lateral force. So lateral force is coming from the retained material or the earth. Now let's see what is earth pressure here and how we calculate this earth pressure. Earth pressure now is three types. If our wall is rigid and it is not moving under the effect of the material retained, then in that case the pressure coming to the wall is called as the earth pressure at rest. But the condition here is that our wall should be rigid. There should be no movement. If there is any movement, either it will be away from the retained material or towards the retained material. If this movement of the wall happens to be away from the retained material, then the pressure, earth pressure, will be called as active earth pressure. If the wall moves towards the retained material, then the earth pressure coming to the retaining wall will be called as passive earth pressure. So three type of pressures are may come to the wall: earth pressure at rest, active earth pressure, and the passive earth pressure. Now this magnitude of the pressure at rest is generally found to be between the active earth pressure and the passive earth pressure. And if you just think about this earth pressure, this is so heavy, this is so intense that even the earth pressure at rest is so heavy or so intense that under the action of this earth pressure at rest, wall moves slightly away from the earth or the retained material. And because of this movement, as I just told you, that if our retaining wall is moving away from the retained material, then pressure will become the active earth pressure. So this earth pressure at rest remains no more at the retaining wall, and as soon as that retaining wall slightly moves away from the retained material, then active earth pressure applies on the retaining wall. Now, as we see that in most of the cases this active earth pressure will be coming on the retaining wall, so most of the retaining walls are designed for active earth pressure. Now let's see how this earth pressure is calculated. So as you see from this figure, this is the wall, retaining wall. Earth is retained on this side, means this is the higher side, this is the lower side. As you see, y1 is the height of the retained material, which is equal to h. Any depth we are calling as y, and final depth is the height of the wall. On the other side, this is y2, the depth of the soil. Now, the action of this earth pressure is analogous to the fluid pressure. So as you must have studied in your fluid mechanics course, that the fluid pressure varies from 0 at the top to the highest at the bottom. So similar here also, in this case there is a linear variation of the earth pressure at top 0 and bottom the maximum one. This is the pressure variation of the earth pressure here, shown as a triangular variation. Here also on the other side, this is also a material, soil, earth is also on the other side. So here again the behavior of this earth pressure will be a triangular one, means linear variation, 0 at the top and maximum at the bottom. But you see here a difference between the two, because under the earth pressure this walls move slightly, and ultimately the pressure coming on this wall is active earth pressure. So on this side, the side of the retained material, the pressure is active earth pressure, and that is shown as PA, subscript A, means this is the active earth pressure. Whereas on the other side, because the wall is moving towards the material, so here the pressure will be passive earth pressure, and it is written here PP, means pressure. This subscript means passive pressure. And as you know from that hydrostatic pressure variation, that the total force or the total pressure act in the horizontal direction if this retained material is level to the top of the horizontal in horizontal position, and it level to the top of the wall. Then this pressure acts in the horizontal direction, and at a height of 1/3 of the total height of this retained material. So as you see, y1 is the height here of the retained material. So this total pressure, total active pressure, acts in horizontal direction at a height of y1 by 3. Similarly, here also the total passive earth pressure is acting in horizontal direction and at a height of y2 by 3, whereas y2 is the height of the soil or the earth on the front side or the other side of this wall. Now, as I told you that there is a linear variation like the variation of a hydrostatic pressure. So here this pressure P is given as K, gamma and H, where gamma is the unit weight of the material retained, H is the height of the material retained here or the height of the wall if it is at the up to the top of the retaining wall. This K is a coefficient which is called as a earth pressure coefficient, and as you know, here either active pressure will be coming on the wall or passive pressure will be coming on the wall. So this K will be used as active earth pressure coefficient or passive earth pressure coefficient. If active earth pressure is there, then this coefficient will be used as active earth pressure coefficient Ka, and this is written as 1 minus sin phi divided by 1 plus sin phi, whereas phi is the angle of repose. Or if this is passive earth pressure, then in that case this coefficient will be called as passive earth pressure coefficient, and the expression or the formula for this passive earth pressure coefficient is 1 plus sin phi divided by 1 minus sin phi. So as you see here, this Kp and Ka, these are the two earth pressure coefficient, and you can see that Kp or Kp is just reverse of Ka. Here 1 minus sin phi is in the numerator, whereas 1 plus sin phi is in denominator. In case of Kp, this is reverse, 1 plus sin phi is in numerator and 1 minus sin phi is in denominator. So if you take a case of the cohesionless soil where phi is generally taken as 30 degrees. So if you put this 1 minus sin phi in place of phi, if you put 30 degrees, then 1 minus sin 30 divided by 1 plus sin 30. Whereas in case of Kp, this will become 1 plus sin 30 divided by 1 minus sin 30. You can calculate these two values and Ka will come out to be 1 by 3, whereas Kp will come out to be 3. Means these are inverse, means Kp is equal to 1 by Ka simply. So this is the case, this Ka and Kp are written in case when this earth fill is in horizontal position. But there may be a situation when this earth fill is at an angle to the horizontal. Then if that angle is delta, then this expression of this Ka will become cos delta minus under root cos square delta minus cos square phi divided by cos delta plus under root cos square delta minus cos square phi into cos delta. Means little bit a bigger expression comes into the picture, and some more mathematics will come into the picture when the retained earth is at an angle to the horizontal. So this is the earth pressure. So up to this stage we studied about the retaining wall, its purpose, its types, and the forces coming on the retaining wall. Now in our next lecture we will study about the design of the retaining wall. Means what are the steps of the design, what are the stability requirement of a retaining wall. So starting with the stability requirement, we will go to the design of a retaining wall. I hope you must have enjoyed this lecture, and with a full interest you will go through your course material and study it, and I hope you will come next time with some questions in your mind. I will certainly clarify and explain your doubts if there is any, and then we will go to the design of the retaining wall in our next lecture in this series. Thank you.